So yeah, DevSecOps, story of three security breaches, right? So I'm going to talk a little bit from the other perspective, the other side of things, and there we go, and paint a little bit of a picture of based on three real breaches that we've worked with customers on, and talk about some of the different failures, some of the challenges that come from those breaches, right? A little bit of a background. So essentially, I've been in cybersecurity for about 20 years now. Run a consulting firm for about 18 years, a SaaS platform in the digital risk space for about 5 years now. So we've been doing this for a while in terms of breaking things. And our job's a little bit easier because we just get to point at problems while you all have to actually go fix the problems, and it makes things a little bit better on our end. So security is a little bit of a funny space, right? You expect things to be done a lot better than it is in most cases. I don't know if anyone's read up on the Uber breach this morning. Yeah, about 10 hours ago, there was a massive Uber breach that's just come out. And you expect there to be a lot more layers, a lot more controls put into place in most organizations. And in reality, it turns out to be a little bit like this, right? Where it isn't exactly what you're expecting it to be. So one of the things that we do as a business is looking from the outside in on how we can break into organizations and how do we sort of, where can we go with those breaches, right? So I'm just going to tell you a couple of stories of different breaches that we've looked at, and what were some of the failures that happened there, and what were some of the improvements that can happen from a DevSecOps perspective to tackle those breaches going forward. Yeah. So three different types of breaches. The first one's a startup, a unicorn startup. The second one's, I believe, a tech firm. And the third one's a bank. So three different sort of interesting environments. So I'll talk about the first one. That was pretty interesting, right? And the intent of this talk is to sort of shift the perspective, right? So typically, again, when we're looking at cybersecurity, and when most folks are building cybersecurity, right, they're looking at each component, each piece. They're trying to build what they think is sort of the best solution, right? But when you look outside in, when you look from a hacker's perspective, things behave in a really different way, right? And what you'll see in the first breach that I'm going to talk about is that they had a lot of things right, and a lot of really small failures took place across the entire set of layers that resulted in a much larger breach, right? So I'll talk about that today. So incidentally, one of the facts that came out from the Uber breach today was that they had two-factor authentication, and the hacker just kept spamming it until the guy just said yes eventually and let him in. Anyway. So the domino effect, right? So really interesting case. This was a real red team that we did for a customer a few years ago now. But I'll talk about the story, right? So it started out, we were looking at their public footprint, found a couple of HA proxy servers that were misconfigured, and basically let us talk to internet websites, right? So we could start talking to internal domains. They weren't essentially checking to see if it's a public portal, right? You could start talking to internal microservices, start talking to internal APIs. We use that to start talking to a Django server, and which is configured to have debug mode enabled, throws a whole bunch of error hashes out at us. We've suddenly got about 6,000 password hashes for internal employees. I'm summarizing a whole bunch of stuff that's happened, but of course, a bunch of misconfigurations that sort of resulted in that, right? And as almost everyone can testify, most organizations have a company at 1, 2, 3, month at year, some sort of nonsense pattern that's pretty much persistent across most of the organization, right? So we took those password hashes, generated a list of company at 1 to 3 kind of passwords, and within an hour we had about a couple hundred accounts that were cracked and plain text passwords available, right? That in turn turns into VPN access. So again, this was before they had two-factor authentication. So we've got VPN, but this is a cloud forward organization. So VPN didn't really have too much, right? It was largely just a gateway, sort of a hop to go talk to their cloud. So post that, it sort of went a little south from there for them, right? So turns out they have a couple of Jenkins instances running on AWS that are whitelisted with their Office IP addresses. We now have their Office IP addresses on the VPN, so we can start talking to those AWS instances. So we can talk to Jenkins. Jenkins is using Google single sign-on. And they did a really interesting thing here, right? And this is, again, a series of small failures, right? As you'll see with the whole story, there isn't one giant fix that could have really helped it. So in this case, they were checking whether the authentication was correct. They weren't just checking what domain was coming back, though. So they were trying to make sure you're actually logged into Google. They weren't checking if you were coming back with the correct domain. So you could log into your personal Gmail or your personal email address. The session would come back, and they would be like, yep, you're logged in, you're good to go, and let you into Jenkins, right? They let you into Jenkins. And you had, dummy screenshots of Google, of course. And they let you see the projects, and we had a certain level of access where we could go and create our own pipelines. Now, again, most folks don't really think about this from a risk perspective, but Jenkins stores a lot of secrets, right? And those secrets, unfortunately, at least until a few versions ago, I believe, are reversible, are plain. They always have to be reversible because the code, of course, has to use them, right? So we go and we create a new pipeline. In the pipeline, we put in a really polite command. Just send an email to my inbox with the secret file and the credential file. Send it out to me. You run the pipeline, the command executes, the secret files show up in my inbox, and there's a free tool on GitHub you can use to decrypt the credentials back from these two files, right? So one's the encryption file, one's the XML file that actually contains the encrypted credentials. So you put them together, and now you have plain text passwords. So everything that's inside the Jenkins credential storage, we have in plain text again now, right? So again, these are just some of the fundamental, and you'll see another one as well that's pretty fundamental as well, that these are a lot of the assumptions you make along the way, and that's kind of the point of the talk. You assume that credentials that go into Jenkins are going to be reasonably safe or reasonably secure, but it isn't really the case, right? So we've got Jenkins access, we go forward from there, and we've got some GitHub credentials that were hard-coded in Jenkins, and we used to check some repositories out as part of the pipeline process. We get those, no problem. They're smart, they've got two-factor authentication enabled on GitHub, everything's good, right? Except an interesting combination happens, right? So if you use the GitHub API, you can query certain amounts of information without the two-factor kicking in. So you can actually get the names of the repositories and enumerate that information. You can validate whether the repos exist without the 2FA kicking in, right? So we could do that, cycle through it, got about 200 repositories that exist, and use the credentials to check those repositories out. Again, so as long as you're on the command line APIs, you completely bypass the 2FA, right? They get an email in their inbox letting them know someone's accessed it, but that's all that takes place. So a control that they believed was secure and in place was completely turned around there, right? So we've gotten past GitHub. We now have access to about 200 repositories of code. A whole bunch of information is obviously stored inside those parameters, right? Turns out again, no jokes, literally this. They had a literal repository called DevOps, which contained SSH PEM files just sitting in that repository. It's true, I'm not making this up though, right? So a DevOps repository, SSH keys stored inside that we were able to obviously go and extract, and we have that now, right? And as much as organizations try, out of the 200 repositories, a few of them contain the AWS keys hard-coded inside them, right? Inherently, there's always going to be a couple of sort of weak points where that happens. So use the AWS keys to go and dump a list of all the EC2 instances they have access to, run a scan across all of those, get a list of SSH servers that are publicly available. We've got a list of SSH servers, and then it was a matter of spending, I think, a couple of days literally just running commands, trying those SSH keys on every single one of those SSH servers with a bunch of different user names that we knew that they had. So I would say about 200 servers in, eventually it hits, and we've hopped onto one of the jump servers with a certain amount of access. Of course, they've left sudo enabled for the particular user. And this was also a common SSH key used across 300 or 400 developers across the organization. Yeah. So jumps from there, right? We've got sudo, we have root access. There's a whole bunch of SSH keys saved onto the particular machine that can access a whole bunch of internal services. We've got onto that, and we've then gone and compromised pretty much everything, right? The final screenshot we had was the production databases, open user table with about, I think in this case, about 45 million user data just sitting there, and that was sort of the end of that red team, right? And this is, for us, this is how most red teams work, right? I think a lot of folks, when we talk about security, right, we're very heavily over-engineering the kind of solutions that are put in place. While the gaps in term are really, really low tech in most cases, right? I literally can't tell you how many organizations we compromise every week as part of our red teams by literally just using month at year as a password, right? Capital month at the rate year, go back the last 6 months and brute force that across your Active Directory, and I promise you, you'll get at least about a 10% hit coming back, right? Especially if your organization's one that changes passwords every month. Right? I mean, show of hands, do you all know if there are patterns in your organization? Where you see those sort of patterns, right? It's incredibly common. The point being that failure comes from a lot of these small changes, and in this particular breach, right, it went from complete public access to production root on internal servers with no one fundamental flaw. It wasn't one big glaring CV, one big glaring patch missing, right? It was a whole bunch of really small stuff that they wouldn't have prioritized as P1, right? SSH being publicly open probably wouldn't have prioritized it. HA proxy misconfig probably wouldn't have prioritized it as a P1. When put together, it all comes back and snowballs into a much, much larger sort of impact, right? And that's the pattern that we see at most places. So yeah, that was one of the breaches that was pretty interesting. And I'm going to talk about a couple of different ones that are different pathways, right? So the next I'll talk about is the weakest link, right? Pretty interesting one. So this was, I believe, a tech IT firm, a tech consulting firm. Pretty large firm. They'd done a reasonably good job in terms of the security, right? Everything was behind VPN. Public footprint was an absolute minimal. Most things were behind single sign-on. Everything was 2FA enabled, and our red team was pretty frustrated, right? Like they'd spent a couple of days scanning everything, looking for data leaks on GitHub. Nothing came back. They pretty much couldn't find anything out there, right? A couple of days in, somebody gets lucky and they find a SQL file on Pastebin, I believe. That was a SQL backup, or I think a Pastebin or GitHub or one of those. There was an SQL backup of a ticketing platform, right? But again, with most organizations, security kind of is in layers, right? Where a lot of companies focus a lot on outside in, and then once you get past the front door, a lot of things open up, right? And in this particular case, it was a ticketing platform, and literally, I mean, dummy screenshot of Google again, but in that case, it was an SQL backup, and we spent a couple of days just grepping through that SQL backup. There were AWS keys, passwords, signature, SSH files. It turns out anything that a developer needed in the organization, they would raise a ticket for, and somebody from the DevOps team or the IT team would go and provide it through the ticketing platform, right? So again, a single point of failure. Post that, we had access to everything. We essentially, in this case, funnily enough, we were able to compromise VNC passwords, and they had behind the VPN, everything was on VNC, and we had access to a whole bunch of servers, and we were able to go and access a whole bunch of information, right? But again, what you typically see is they had literally done everything else right. It was a single point of failure that resulted in a massive breach for them, and then at the end of the red team, it looked like a complete bloodbath, right? It looked like we'd gotten everywhere, but it was this. Oh, it is play. It was just one literal failure that resulted in this massive breach that was there. And that's kind of the thing that most companies don't look at, right? I mean, what you saw with, what you'll read about the Uber breach as well, right now, that was really interesting, is it was a single account, a single user was compromised through social engineering, I'm assuming phishing or something of that sort. They bypassed 2FA by just refreshing a whole bunch of times and frustrating the guy into giving access away. And apparently it seems that there was admin credentials on a network share, just sitting in a power script or something of that sort, and then everything sort of fell from there, right? And you'll see in the news over the next couple of days, but they've got financial information, they've got user data, they've got a whole bunch of really interesting stuff. And same thing, right? Outside in is probably really secure, and once you're inside, things start falling apart. So yeah, that was another interesting sort of story that we had, right? The third one's a really interesting case, right? So in this case, it was a bank. And it was one of the new cloud-first banks, right? Because the traditional old-school banks are a lot easier to sort of go after because they have got massive legacy infrastructure. They've got a whole bunch of stuff that's out there, right? The new cloud-first banks, they've outsourced most of the stuff. So most of their processing, servicing is outsourced to vendors. Most of their processes are on the cloud. Most of it's on SaaS services. So their footprint's a lot smaller, right? Did our initial scans, couldn't really see anything critical. Most of the things we were able to compromise a whole bunch of stuff, but it was all sitting on AWS, and none of their core banking processes were actually in the cloud, right? They were all on-premise in their data centers. Only their marketing portals and websites and APIs were on the cloud. So we got access to some stuff, but nothing that was really letting us get into the network, right? Really letting us get some serious access. So we decide, okay, let's go after the human element, right? Let's try to social engineer these guys, and let's see if we can compromise someone. Sent a phishing email out. Within the next hour, our phishing domain's been taken down. Their SOC guys picked it up pretty quickly, blocked our email off the network, blocked our domain, literally took it off the internet, got it taken down, right? So we're again back to square, we're back to zero, and we're not sure where to go from there, right? So we start thinking outside the box, and we have a couple of guys start visiting their offices and start trying to look at how do we actually get inside, right? How do we get something? It's embarrassing to go back and be like, hey, we didn't find anything. Right? Here's your bill. Yeah, it doesn't work well. So we got our folks to go visit their office, and they come back. And these guys, they had an office at the top of a building. It was a shared building, so there was a bunch of other businesses across the floor. So we actually go and we realize that everyone's using the common elevator, right? So you have a bunch of folks, and I don't know if you've, a lot of these office buildings around lunchtime get really crowded, right? So you have a whole bunch of people packed in this elevator, and everyone's got their RFID card dangling at the hip, pretty nice and conveniently. So now you get the Flipper Zero, whatever RFID reader. At that point, we bought something off AliExpress, pretty much literally. That's the actual photo. Where it was an RFID reader, it was a little gun you could use to beep and read the RFID card and then go write it on a blank and essentially make a copy, right? So we literally got in the elevator. We had our guys go up and down for a few hours, trying to inconspicuously try to scan somebody's RFID card. And eventually they get it, they scan somebody's card, make a copy, we go and get some fake lanyards printed and all the other stuff that we need to go with it. And we're able to pretty much just walk into the office at lunch hour, right? Put on the clothes, look like one of the employees, go at lunchtime and it's a bit of a rush, walk right in and you're into the organization, right? That was the first step. So we got inside, we've got progress. And then we'd taken the phishing attack a little bit personally, right? I mean, they blocked us, they'd really embarrassed us with the phishing attack because they'd taken the domain down in like an hour or so. So we went and this is actually a photo of the guys in their actual office, wearing a hat with my company logo on it to sort of add insult to injury. But this is what I got back on the WhatsApp group to sort of confirm that, yep, we've made it, we've got it, it's worked. But yeah, anyway. So the guys get inside, they start walking around, they find a couple of empty desks, and these guys had an open sort of planned sitting area. They find an empty desk where somebody's not showed up today or something of that sort. They've got a little Raspberry Pi, they've got a tiny Wi-Fi router, they plug both of them into the network. Nothing to authenticate on the network in terms of MAC authentication. So we're on the LAN, we've got a Wi-Fi access point that we can reach from the lobby outside. We've got a Raspberry Pi that we can use to sort of host things, right? So they set up a phishing attack on the LAN, on the Raspberry Pi. They send a new phishing email out to a really limited audience within the organization. And because it's hosted on the LAN, it's not really hitting the web filter on the way out, right? We're ahead of the web filter, so we're essentially able to bypass that control, get the folks to give us access. They give us AD credentials. AD credentials open Citrix up. Citrix is open from the internet because, of course, it needs to be open. Log in, find a whole bunch of stuff there. And once that Citrix opened up, again, there were file shares, there was a whole bunch of data. There was just tons of stuff that opened up, and it all sort of went from there, right? And that's typically what happens. So the big takeaway, right, is security very, very, very often, very rarely is a massive breach, right? It's very rarely going to be a single vulnerability. That's the one that's going to get compromised. It's going to be one big sort of thing, an event, and that's what everything's going to fall from there, right? It's always going to be a set of iterative small steps that are going to result in a much larger impact, right? Yeah. So again, I mean, the idea is, right, security, don't just hang it on a wall. You have to test it out, right? So stress testing it, evaluating whether things fail or don't work, right? So we see this all the time when we do red teams. One of the nice parts about doing these sort of engagements, right, is you can test the response from the SOC or the WAF or the outsourced response team that you have, right? Do they actually show up and be like, hey, somebody's broken in? And most of the time it doesn't happen, right? We've had cases where we've found vulnerabilities, purchased Facebook ads to hit some particular set of URLs so that the SOC starts getting alerts coming from all over the world because of those Facebook ads, and they get overwhelmed with the number of alerts, and then we can go and actually pull off an attack without the SOC responding to it, right? So that's the nice part about these sort of engagements, where you can actually evaluate the response, make sure things actually work the way they're supposed to work. And this is, again, the disadvantage that most of you all are at, right? Is we have to find one thing to sort of really break in. And SRE teams or dev teams or operational teams have to fix pretty much everything, right? So the math doesn't really check out there. And the challenge is that a couple of small bugs that have been missed out can sort of end up with a really critical issue and a critical compromise, which is sort of the equation that you need to look at, right? There was definitely one more slide, but I think I missed it. Anyway, so yeah, the point was that, right? So you have to, the key takeaway of anything, right, is that you need to stress test those implementations. So whatever security controls go into place, right, do they actually respond under load, under stress? When somebody's actually trying to actively get around them, does it actually work, right? We've had red teams in the past where we've literally just called somebody up and gotten on the phone and been like, hey, I'm talking from X, Y, and Z office. I need this information. Or we've interviewed folks for jobs all the time, where we'll call somebody up, say, I'm calling from competing bank, I want to hire you. Can you tell me about your day? Can you tell me about how you manage the particular proxies? Tell me some information about how you set things up, and they volunteer a whole bunch of information, right? So there's a lot of gaps and angles that you don't really factor for when you're building security, and that's where a lot of the challenges come from, right? So yeah, that's pretty much it. Some of my information. Any questions in the meanwhile, I'll be happy to answer.